Lesson 8.4, Partial Fractions. Partial fractions are used to split a rational function into smaller fractions. It's like taking 5/12 and splitting it up into 1/6 plus 1/4. Only it'll look more like this with functions instead. To find partial fractions, first of all, factor the denominator of your function. For each linear factor of the denominator, we put a over the linear factor. If that linear factor is repeated, you put the next letter over the function squared. So you'd have it, the factor first, and then have it again for every time it's repeated, just with the next exponent. Quadratic factors. The numerators are ax plus b. Instead of just a single letter, it's letter x plus another letter. And again, if the factor is repeated, the second time it'd be squared, the third time it'd be cubed, and so on. The idea is to solve for a, b, c, d, etc. So you'll multiply by the lowest common denominator, which will always be the denominator of the original function. Choose convenient values of x, define a, b, and c, or create a system of linear equations based on the coefficients of x. So let's look at some examples to see how this works. Find the partial fractions. All right, first step was to factor. So we could factor this denominator. To get x squared to be x times x. To get 8 might be 4 and 2. That adds to make the 6 in the middle. All right, so we're going to say these are each linear factors. So it's a single letter over the first linear factor plus a single letter, a different one, over the second linear factor, and neither of them are repeated. Then we're going to multiply by the lowest common denominator. So I'll multiply by x plus 4, x plus 2. X plus 4, x plus 2. X plus 4, x plus 2. And cancel what cancels. So on the left, the entire denominator should cancel. On the right, only part of it does. So you have that left. All right, now we could do this a long way, but this is set up beautifully for a shortcut. We can pick convenient values of x, such as if x was -4, b would become, would disappear, be eliminated, and I could find a. So if I plug in a -4, I'll end up with 4 equals -2 times a plus all that becomes 0. That's why it's so convenient. And you can tell now a is -2. Well, we could do the same thing to get rid of a. We could say x is -2. So if we plug in a -2, we'd have 6 equals, all that becomes 0. This becomes 2b. So b appears to be 3. So now that I know a and b, and go back to my original thing, which was a over x plus 4 plus b over x plus 2. Just fill in the original expression. Let's try another. Let's find the partial fractions for this one. So we're going to start by factoring the denominator. Oh, I can factor out an x. And then to get x squared is x times x. To get 1 might be -1 and -1. So we have 3x squared minus x plus 5 over x times x minus 1 squared. Those are both linear factors, so we have a over x, b over x minus 1, and the x minus 1 is repeated, so it gets a different number, and the x minus 1 squared. That way we have it squared over on the left. So now we'll multiply by the lowest common denominator. So I could multiply by x times x minus 1 squared, x times x minus 1 squared, x times x minus 1 squared, x times x minus 1 squared. So on the left, it all cancels. And then with the a, just the x cancels. So it's a times x minus 1 squared. For the b, one of the x minus 1's cancel, so it's bx times x minus 1. And for c, both of the x minus 1's cancel, so it's cx. All right, for this one, we can pick a value that eliminates c and b. We can pick a value that eliminates a and b, but I can't pick a value that eliminates a and c to get the b. So the convenient values don't necessarily work. So when that happens, multiply everything out. So it'll be a times x minus 1 squared. We already had that up here. So that is a times x squared minus 2ax plus a. And then for the b's, it's bx times x minus bx. And then let's collect like terms. So let's collect the squareds. So I'll have a plus b x squared. Just the x's, we have -2a and -b. And c. And then just the numbers, we have a. So now we have these coefficients. The coefficient of x squared is a plus b, and on the left, that's 3. The coefficient of just x is -2a minus b plus c, and that equals, and the left side, that's -1x. So we're just looking at the coefficients. A is 5. That's just the constants with no x. Well, conveniently, we know a is 5. So then we can substitute that into the top equation to get b is -2. We can plug both of those into the middle equation to get c. So c appears to be 7. So our answer is, if we go back to what we had here, it's a, which is 5 over x, plus b, which is -2 for x minus 1, plus c over x minus 1 squared. Let's try another one. If you notice, the bottom is already factored. It's quadratic because it has the square as x squared, and the square on the outside means that the factor's there twice. So when we write this out, since it's a quadratic factor, the top is like ax plus b, and the bottom is the quadratic factor, but it's repeated. So that would be cx plus d, and when it's repeated, the factor is squared. So we split it up. Now we multiply by the lowest common denominator, which is always the denominator of the original function. So it cancels on the left. The a and the b, 1 cancels, so it's ax plus b times x squared plus 3. For the c and d, the entire denominator cancels. This one, we cannot do convenient values because we can't even get rid of the 3 with the x squared without using imaginary numbers. So we're going to have to multiply this out and make a system of equations. So I have ax cubed, bx squared, 3ax, and 3b. Let's collect like terms. So I have cubes, which is just a, squareds, which is just b, x's, which is 3a plus c, and constants, which is 3b plus d. So now I write my system. For the cubes, I have a equals 6. Well, that's convenient. For the squareds, there is no square on the left, so that means it must be 0. For the x's, 3a plus c equals 16. And for the constants, there are no constants on the left, so the 3b plus d would have to equal 0. Well, we already know a and b, so we can take our third equation and we can fill in the a, which was 6. And we can finish solving for that, so it'd be 18 plus c equals 16. So c is -2. Take the bottom equation, and we can fill in the 0 for b, and we get d equals 0. So I know a, I know b, I know c and d. So taking and writing our answer, it is a x plus b, which is 0, over the x squared plus 3 plus cx plus d, d was 0, over the x squared plus 3 squared.